Today we are going to talk about, today's the 15th. We're going to talk about limits of rational functions. So before we start, we need some definitions. The first definition is rational. Oops, spelled that wrong. Please let me know if I'm going too fast. Oh, there you go. Good morning. Function. A rational function is a function created using a fraction where the numerator and denominator are different functions. Where the numerator and denominator are different functions. As soon as you see the word rational, it should tie into fraction. Automatically, whether it's a rational number or a rational function, it is a fraction. You're going to have something in the numerator and something in the denominator. That's not just one. Okay? The numerator can be one, the denominator is something else. Okay? Excuse me. Thank you. The next definition we have is discontinuity. And we'll talk about that in a minute. But discontinuity are point, or is a point, or points, or value, or values. On a graph. Or of a function. Where the graph, has no value. Where there is no value. Or does not exist. When you're done writing that down, on the front of the paper, I'm going to turn on a little bit of the light. Okay. On the front of the paper, you're going to see half the paper are limits. So it says find the following limit, use the graph, and then number 4. So you're going to have 1, 2, 3, and 4. I want you to use, before we get into today's full lesson, I want you to use your prior knowledge to complete these. Your prior knowledge. Use your notes, use each other, ask us questions. But I'm going to give you, let's see, one. Everybody have a calculator, by the way? If you don't, get one. I'm going to give you about 6 minutes. 6 minutes. Okay. Get all of those done. Get all of those done. Make sure that you have a calculator and make sure that you know how to put a fraction into your calculator. There we go. Much better. You can talk together. You can talk at a level 1, but you should be on task. You should be on task. You should be working on 1, 2, 3, and 4, right above where it says level 1. Yeah. Number 1 and 2, all you're doing is substituting in. Remember, when you get something that says error or cannot divide by 0, what did we say it was? Remember, when we have a denominator of 0, what is it? What did we say it was? Remember, alpha y equal is the fraction. Did you put the negative 4 in parentheses? Yeah, it's negative. Got 3 minutes. See, a lot of people have gotten finished the first part. Some people have completed the graph. Some of us are stuck on number 4. Remember, what can you do if you have the same thing in the numerator and denominator? What can you do if you have the same thing in the numerator and denominator? What can you do? Okay, so all you're doing is substituting in for number 1 and 2. That's all you're doing. Emily, you good? Oops. When you divide by 0, and do 8 divided by 0, you calculate. So when you get that, what's the limit? Does that exist? You have the same thing in the numerator and denominator. Divide that and leave it. What's going to be 0, Did you do alpha y equal? Did you put it in parentheses? You sure? No. Are you putting 1 in there? No, you don't put the x, you put whatever the x is. What is the x? Yeah, remember? Alright. Okay, let's look at the first one, or first two. When you put this in your calculator, what did you get? What did you get when you put in this calculator? Does not exist. Does not exist. Does not exist. Because when you substitute in 2 in here, you will get 2 minus 2, which is 0. You cannot divide by 0. When you substitute in -4, you'll get something over 0. You cannot divide by 0. Okay? Let's look at the next one. What did we get for the limit as x approaches 2 from the left? Remember, we're going to this one. We got 5. Yes, all of the things that we have done so far are coming together. What do we get when we go from the right? Also 5. So then what is this limit? 5. Questions on that? This is all coming together, guys. So what about this one? What can I do to the numerator and denominator? Cancel them out. So that means these become 1. So I can rewrite this to be the limit as x approaches 2 of x plus 3. So now what can I do with this? Plug it in, substitute it in. That becomes 2 plus 3. So the limit is 5. Okay? This is all prior knowledge that we've been doing. All prior knowledge. If you don't remember, come to office hours. Did I do something wrong? Okay. What if I told you that this example, and this one, where we got does not exist, are all the same thing? Diego, thanks for the audible gasp. Thank you. This one and these two are the same problem. You're like, wait, what? But there's limits here, but no limit here. In math, we can take out those discontinuities and find the limit. Yeah. That is because we use factoring. Why do you think I had you factor the last week and a half? Factoring to take out those things that make it 0 or make it does not exist. Let's go back to our notes. Got to write down a few things before we get to the lesson. All right. So, in calculus, we can remove the point or value to calculate the limit. where the denominator is 0. By factoring and canceling out the factor, then use limit rules, meaning that we're going to substitute in. Almost done. Ready? Yes, no, maybe so. I see some people still writing. Okay, so we're going to talk about the different levels and what we're going to do to use, what we're going to use to solve them. Okay, so the first thing we're going to do is level 1. Level 1, we're going to use tables. Use tables, I don't know why I didn't put a space in between them, to find the limit. We're going to use tables. I will show you what this means in a second, okay? First thing you're going to do is you're going to find the left side limit. So remember, it's going to be the limit as x approaches a from the left of f of x, and it's going to be equal to some number b. I want you to, where possible, to round to 2 decimal places. Round to 2 decimal places. You'll see what all this is in a second, okay? The second thing you're going to do, am I going too fast? Anybody? The second thing you're going to do is you're going to repeat it, though, for the right side limit. Oh, sorry. So basically this is, sorry, my bad. Find the right side limit. Sorry. So repeat for the right side. Repeat for the right side. Then you're going to evaluate using limit rules. Evaluate using rules. If 1 and 2 are equal, what does that mean about the third? It's the same, right? So that's what I mean by evaluating limit rules. What if they're not the same? What? Say louder. Does not exist. Okay, so this goes back to what we were doing way before. Yes, we're combining all the things we've learned so far. When you're done, take out your sheet with all of the examples on it. When you're done, take out the sheet with the examples on it. It should be on the bottom left. Oops. Are we ready? No? Yes? I still see people writing. That's okay. Ready? Ricardo, Kimberly? Ready? No? Is anyone ready? Okay. All right, so let's look at this example. We have the limit as x approaches 2 of this function. If I substituted 2 into here, I would get my denominator 0. And we said way back that if your denominator is 0, it does not exist. But now we have ways to calculate whether it exists or not. So here are the table of values. We all have seen Rain. We don't have to look at there. Here are the table of values for this function close to 2. So as you see, 2 is undefined, meaning that the denominator is 0. So I'm going to use this like a number line, okay? If I come down here, this part of the number line is from the left. Because if I use this as a number line, to the left of this is from the left side, to the right of this is from the right side. So if I used this as a number line, that would be from the left, and this would be from the right. Any questions so far? Gentlemen? So what you want to do is you want to look at the y values. You want to look at the y values, to find the answer. So we need the limit as x approaches 2 from the left of f of x. So if I go down here, what is this getting closer and closer to? What value is this? What is this round to? What kind of 2? Negative 2. Can't just say 2. It's not just 2. So now we've done from the left. So that's that first part. Now we have the limit. As x approaches 2 from what side? What is my next thing? Look at your notes if you don't know. From the right. So now I'm going to go this way. So if I look here, what is this approaching? What's it getting closer and closer to? What value? No, not 1. Not -1. -2. We're rounding this to -2. Do you see that, Oscar? You sure? Okay. You sure? Okay. I'm not trying to call you out. I just want to make sure you understand. What's going on with these two numbers here? They're the same, which means that the regular limit is -2. Questions on that? Are we sure? We sure we're sure? All right, then flip over the paper when you're done copying this down. You have 2 problems to work on. I'm going to give you 3 minutes, and then we're going to go over the answer. 3 minutes. I'm going to run to the bath. We should not just be sitting there. Can you make sure they're working, actually? Especially that front room.
The same thing she did for the other problem. Like label it like the right ones, the left ones. She was like, you see both supposed to be. Yeah. She lives like she did.
Never mind.
What's the advisory?
What day is it today?
No,
I'm trying to think of
so everyone just calls it like your. I'll put it in my guest bed. Thank you. Take everything with you. Yeah. Need a large conference room? I believe so. I have one at the office during the fires.
in the what?
Drill.
Also. Okay. Oh, look at that. Well, that's today, isn't it? That's today? Is that today?
This is depending on weather.
What? We're gonna get hit by motor?
No.
That's not even funny. Oh, yeah, that's not funny.
That's hilarious.
I don't know. It depends on the weather. All right.
Based on the weather.
All right, seniors. Do you hear that? I hear somebody's phone.
Nah, it's crazy.
Like a vibrating, right?
That was yours.
No, my phone doesn't vibrate.
You do, right? I wonder if it's Mr. Brown's room.
Oh, yeah.
Okay. All right. Let's go. Ready? So we need the limit as x approaches what? 3 from what? From the left. Thank you. What does that give me? 8. Are there any questions on that? Then we have the limit as x approaches 3 from the right. What does that give me? 8. So remember, this is from the left, this is from the right. Which means, what is my regular limit? 8. This is what your exit ticket should look like. Okay? This, you have 2 questions. That's it. I'm going to give you a quick view on what it looks like. That's what it looks like. Hey, look, looks exactly like this. No, not crazy. Questions? Are we sure? Okay, here we have the limit as x approaches what? -2. What is that going to be equal to? And this is where students got it wrong in last class. Not 0. Remember, it's 2 decimal places. So we're rounding to 2 decimal places. What's that going to be? -0.08. Don't change the number, okay? Don't assume that it's going to 0.5 or 0.05. Oops, that should be from the left. What about from the right? What is that? -0.08. Which means that what? They're the same. Questions? We sure? Okay. We good? Okay. Now, let's look at level 2. Can I move this? Everybody got it down? Tanoch, you ready?
Yeah.
Okay. Daniel? Okay. All right. Level 2 now. We're going to use algebra. But guess what? Level 2 is just like that last example we had. Level 2 is going to be just like that last example we have. So the first thing you want to do, sorry, I should have said we go back to our notes, is you want to find the common factor or factors, common factor or factors, in the numerator and denominator. When you've found the common factor or factors, because it could be 1 or 2 or 3, okay, you want to cancel, and I say cancel because I don't know of another mathematical term, I guess, other than divide, but then that would confuse you sometimes. Cancel out the factors. And then replace any with 1 where needed. Oops, can't spell today. Next, you're going to rewrite and substitute. Rewrite and substitute. When you're done writing that down, take out your example sheet. Ready? Alex? Ready? Okay. So let's look at this. We're going to find our common factors for number 1. What are our common factors? What's the common factor in the numerator and denominator?
3.
Not 3.
2.
Not 2.
1.
Nope. Remember, parentheses are factors. Parentheses are factors. So what is my common factor? X plus 3 is my common factor. X plus 3 is my common factor, so I'm going to cancel them out. Factors can be parentheses. Factors, these are called binomials. Factors can be binomials. Is this not on your paper? It's on the front. Sorry, my bad. It's on the front. So after I've identified my factors, I'm going to rewrite it. Oh, I'm sorry. I canceled them out, so they become 1. Now, if there is nothing in the numerator, and you'll see that in your next example, that there's nothing in the numerator, it just becomes 1. X approaches negative 3 of x minus 6, and then I substitute. So I have negative 3 minus 6, and the limit is negative 9. All I did was substitute in, put it in the calculator, I got negative 9. Questions? Are we sure? Some of us look confused. Some of us are sleeping. Yeah.
You don't put the fx in there?
Well, I canceled out the x minus 3, so I rewrote it to just be x minus 6. So then my final answer would be negative 9. Okay? So if you did the limit as x approaches negative 3 of f of x, that's fine. Okay? All right, let's look at number 2. What are my common factors? X minus 4. So I identified them, and now I'm going to cross them out. Questions? Now what do I need to do? Rewrite it. So we have the limit as x approaches 4 of 2 times x plus 8 over x plus 7. Now what do I do? Substitute in the 4. So we have 2. 4 plus 8 over 4 plus 7. Wait, did I do it right? So we have 24 over 11, right? Questions? I think I might have wrote that wrong on the example sheet, right?
No.
I have, huh? No, I was talking to Mr. Escobar.
Yeah, 24 over 9.
Yeah. How did I do that wrong? Questions? Are we sure? Okay, then turn to the back. You have 4 problems that I want you to do with your group. I'm going to show you this one really quick. So, what do I do for this one? Cancel it out. Now, because there's nothing else in the numerator, it'll just become 1. So it's going to be 1 over x minus 3. I wanted to show you that one. Okay? Questions? Yeah.
Would be the same if it's for
I'm sorry?
I was asking if it would be the same if it was like.
Yeah, you can put it over one, but it doesn't matter. Okay, I'm gonna give you about 4-ish minutes. We'll go over the answers and then we'll take the 2-question exit ticket. Good, good. I see a lot of you crossing out the correct ones. Remember, all you're doing is you're canceling out the common factor, rewriting, and substituting it in. Canceling out the common factor, rewriting, and then substituting it in. This would be on, right? I see a lot of us canceling and rewriting, but we need to make sure we're substituting it in also. Remember, the fraction button is alpha y equal, enter. Alpha y equal, enter. Alpha y equal, enter. Any other coefficients will remain in the numerator. Yeah. 2 minutes. Don't put those yet. Good? Don't take these yet. Don't take these yet. Mr. Escobar, I'm passing out the exit ticket. I'm telling them not to take it. I see a lot of us canceling out and rewriting, but don't forget, you need to substitute it in. Don't take these out. No, it's not. What's going on here? Why don't you substitute? In here, in here. Yeah, but you substituted in there, why didn't you know those, or you know how to do it, and you're just like, yeah, you see it, you just can't do it. Here's my button. What did you get for number 4? Did you get 2/5? All right, let's look to see if you got the right answers.